is our problem. This is the beam is rotating, and we have an axial loading 35 kilonewton, and we also have a radial loading 450 Newton, and so for this is we want to calculate. This is the infinite. This is a safety factor if we want to have infinite number of cycles to fulfill it. So what should we do? We calculate the SU, and we use this equation to calculate SE, and then the SE prime equals 0.45 SU because the axial loading is dominant. This axial loading, and then I wrote here. So here, okay. So at the point A, and because of bending, and so this is what we calculated for the bending, maximum bending, if we find it this way. And we have MC divided by I, so we get 45 megapascal. And then we have axial loading, so this axial loading and equals 17.82 megapascal. So after we get these two, we need to get sigma A maximum and sigma A minimum. And sigma A maximum, one we can get this sigma A maximum. So when these two guys, they are in the same direction, right? You guys agree? When in the same direction, the axial loading is the tensile, and when point A is on the top, that is also tensile. It's the tensile plus tensile, and then we have maximum. So therefore, A maximum is sigma maximum bending plus sigma axial. So we have this value. So this is our maximum. However, for sigma A minimum, for the axial loading, okay, axial loading is still this is a positive. Axial loading is still positive, but now this is a maximum bending is in the opposite direction, right? In the opposite direction. As a result, we have this is the 44. I'm sorry. So we should have plus here. We should have plus here. I did not change. We change it here plus. So minus 44 plus 17 for the 2 megapascal. So this is our sigma maximum minimum, and then we use this equation to get sigma mean. Mean means the average of these two guys, and now we can see these two, this and cancel this out. So this plus together divided by 2 and 17.2. So say sigma A alternating. So this is the range of this is the sigma divided by 2, so which equals 44. The result is correct, but when I talk about so these two, I made a mistake. I'm sorry about that. Right? So the final results is correct. So the one most important thing is that when you calculate sigma mean and sigma A, and don't change them, don't swap them. Especially for here, when you use this equation, so this is the sigma A, so this is the sigma M. Any questions regarding this example? No example? No question? Question?
Is this sorry? Is the safety factor still 4.3 if we change the?
Yeah, this result is the same. But when I talk about here, I just made a mistake here. So this here should be plus. Okay, if we can just use a plus. Plus, then we can have minus sign here. Questions? So this problem shows us how to use this is the Goodman theory and to solve the problem. You can see what is the output. The output is the safety factor, and if we want this